Now. And now I would like to introduce our next speaker. So I just want to show the pictures briefly. So Michael Samarin from Futurice, it's going to talk about stuff. What's their background of the buzzwords? So what are all the nice things? What the industry has been talking a lot? What are the nice things? What the customers are talking? So what's really the story behind those? Welcome, Michael.
Thank you. Hello, and thanks for inviting me.
Yeah, that's really cool to have you here.
Yes, thank you. Okay, so what I wanted to share for this seminar is how to take beyond the buzzwords, the technology adoption. And today I would like to bring 3 examples regarding DevOps, data, and AI that we hear in our industry pretty much all the time. And I would like to bring 3 examples from some of our clients and maybe a little bit inspire you that even the smallest steps and very holistic and pragmatic approach to how you're starting to adopt a specific technology or even the methods or even how do you approach those, these can lead, all of those can lead to different kind of gains and achievements. And as the being an international company, we have opportunity to learn from clients from different countries and to see how the technology adoption and digitalization is going through clients in different countries. And what is interesting is that here in Finland, we are actually in a pretty solid space, and we see how the digitalization through the society, through our public services, and through our clients is actually on a pretty good level. That said, there is so much that we can learn and understand from each other and from how different companies are taking the next step. And technology specifically, of course, and that resonates extremely well with the Jukka, with the previous talk. It requires a budget, it requires money, it requires scale, and traditionally, from some of the estimates, what we see, the horrible picture when we're concentrating only on the adopting specific technology without thinking of the consequences and how effective it can be or how it can have an actual real impact for our services. What we can see is that sometimes up to a half of our R&D budget is essentially either waste or duplication. And this is a horrible statistics, and that's sometimes this is a best case scenario. And what I would like to do is I would like to actually bring one historical lesson from the 80s again, that even so we are hoping that there is a magical silver bullet of the specific technology or a specific approach which can move us significantly beyond our competition or deliver better services. The fact is, there is no silver bullet. And I would like to bring the very famous article of the Fred Brooks, who also a famous author of the Mythical Man Months, which was published in Computer Magazine in '87, Essence and Accidents of Software Engineering, which is essentially known as No Silver Bullet. And despite the fact that the article is more than 30 years old and it's been challenged multiple times, the main idea, in my opinion at least, still very relevant. And the idea is that software is incredibly complex. And this is the essence of the software. And why is it so complex? Because essentially software is abstraction of our mind. It's an abstract that we're trying to channel and interface into the physical world. And of course, that's going to be a problem. And I would like to encourage us and the companies to look at this actually from the complexity problem. And if we would approach how we would solve specific problem from the complexity, then we would also understand and encourage ourselves to perceive the problem and solutions from this side. For example, that like a simple problems, they require simple solutions, and the complex problem, they actually require a complex solutions. And if you look at these two pictures, that essentially it is exactly the same thing. So we are hitting one thing with another. Only on the one side, it's a hadron collider, it's a particle accelerator, and on the other side, it's a hammer and a nail. So essentially, they're doing one thing, like hitting one thing with another, but the complexity and everything that is involved is completely different. And what we've been observing is that the technical teams, they do have a tendency to overcomplicate the solutions, and the business team and management teams, they have a tendency to oversimplify the problems. And how to find this common ground, that's the problem, and that's how we are trying to learn from each other and see what kind of approaches can lead to better results. And of course, it means that we are being bombarded nowadays with all kinds of buzzwords. And if you are a modern technological leader in the modern corporation, you are bombarded with this all the time. And today, as I mentioned, I would like to stop on three buzzwords: DevOps, data, and AI, and take them one by one and bring you a very interesting, very simple and inspiring example from our clients. And let's first talk about DevOps, which is traditionally nowadays is understood as the development and IT operations are working continuously together. But the interesting fact, if you look at the traditional functional silos of our organizations, and especially the large corporations, that we see functional silos. And this whole process when we are actually delivering IT solutions is mapping those functional silos to the traditional functional approach, where we have a specific teams, analysts, architects, development, Q&A, quality assurance, etc., etc., etc. And this leads to the situation that previous speaker was also bringing up, that if we look only from the cost perspective, and even if we deliver a specific solution in time, scope, and budget, we consider it as a success, even though it's exceptionally rare to do so, but there is so much beyond that. And we can't really look only at the scope, budget, because what is, unfortunately, it leads to the following situation where the development team or a delivery team is creating the solution and then handed it over to continuous maintenance, etc., etc. And this is a reflection of these functional silos that we're observing in organizations when there is a continuous handover and handover and handover. And it leads, of course, to the difficulties in maintenance, technological debt that is being created under the pressure, and the people are allocated to too many projects. So what is the solution is in here. And when we start to holistically apply the DevOps and then trying to bring the understanding that the code becomes legacy, essentially, when it hits production. Once you're starting to understand that, then the switch is being done, that it means that we have to be in a continuous mode all the time. And the software, it's actually not a product, the software, it's a process. And if we look to the a bigger picture, we are starting to realize that organization, not the software, but organization is the problem that we are trying to solve. And with that, if we look traditionally at DevOps as a development IT operations, we actually have to add one more component there, which is crucial. And without this component, nothing is going to happen. And this is an organizational change which allows, infuses, and encourages the development and IT operations linked through the business, linked through the real usage, linked through all kinds of metrics to create this continuum that is working all the time. And I would like to share with you one anecdote or urban legend that I've heard some time ago, that in the history of one of the largest cities in the world, in the history of existence of the subway system or in the metro underground, there was not even a single day when it was not maintained. Just think about that. That's reflection of the physical world, and how we can then think about our software, which is once created and shipped, and then it goes into the maintenance and then goes back to development, maintenance. Uh, that's how we should move forward. That's how we're supposed to approach our holistic view of the DevOps. And I would like to share with you a story of one of our clients where we have created together the DevOps team, where all of these components are working in parallel simultaneously, and that's Finavia. And of course, we have to think back at the normal operations of Helsinki Airport, for example, where the single very small team creates and continuously maintains across several years the very large part of the consumer facing services. Those are the parking reservation systems, those are websites, those are indoor navigations, etc., etc., etc. And that's the entire team that we are talking, where there are few roles, including everything, and the most important part where the business and product owners are essential part of the team. And it leads to the situation where we have a continuous mode and priority driven scope, where essentially team is actually pulling the tasks from the priorities lists, which are created together with the business, understanding implication that are going to be on a system. And the entire process of how those are floating or flowing from one part from one mode to another is the essence of this. And the interesting part is that the entire team is running like 10 to 15 projects in parallel without stress. And there is even another short controversial anecdote where a team at one point have a goal that it would be okay to create a deployment on a Friday evening and be safe and go home, because the entire infrastructure in case of emergencies will roll back and restore every potential fault. Of course, this is like a goal, but that's like how it is. And another critical components where essentially every member of the team is interchangeable within the team. So the team is trying to understand and get and change the roles inside and continuously be within the team, so that the knowledge is in the team and in the organization and not in the individuals. And I would like to also mention that Finavia and the Helsinki Airport is actually a multi-award winner. And if you would like to know more about the whole array of technologies and everything that was used and still used in the project, so you can actually have a very interesting long form article to read about this project. And then if we move forward to the next buzzword, then let's talk about AI. And the interesting part is that at the same time, you can hear AI and artificial intelligence and all kinds of intelligent systems being applied pretty much everywhere. But at the same time, when you start looking at your own business, you are at the same time kind of puzzled. What's in it for me? How I can actually, instead of having a major IT spending and buying something or trying to create a system, intelligent system to solve specific problem. And if we take a look back that traditionally, if we have a problem in a software development, in a programming, we are looking at the essentially if then else. But what happens if we have a data in our problem which is very complex? And that's very interesting. So one way to scale and to solve the problem is, of course, to create extremely complex the logic. But if we look into the history, so the idea was, what is there a system which is actually being able to solve this without creating the logic? So if we do have a set of data and we have a samples and we know the potential inputs and outputs, can we actually train the system? Of course we can. And of course, in the 50s and the 60s and even in the 40s, the idea was that if we peek into how our neural system is actually working, then maybe we can correlate and create mathematical models and simulate that and to take this part of the training. And that's where the AI is coming into the picture, where we can say that the neuron is a mathematical function that takes some inputs, and based on specific algorithms, it produces some output. And that's the whole entire field of artificial intelligence and the neural networks was born, where we can not only the train system on the samples of data, but also we can do the generalization of the data and feature extractions. And also we can essentially create the data that didn't exist in the original data sets. And today we see multiple applications of that in every aspect of our life in terms of prediction, personalization, etc., etc., etc. However, how we are able to apply that in our everyday business when you are working in an organization and you're trying to take something from that and start applying in your business. And that's, of course, you need data. And that's where the problem starts. That in the modern organization, unfortunately, what we observing, there is no clear data governance. There are no clear data maintenance. And essentially, before moving to intelligent solution, you should get your data in order. And unfortunately, what we see, especially from the management perspective, that like a short-term benefit of using, let's get another Excel versus the long-term understanding how the data should flow through your organization and how you expose it in the critical components in order to make certain decisions or in order to being able to apply some intelligent solution. So the data governance, data maintenance, data accessibility, and transparency, these are the 4 components that we encourage the organization to look at before they are starting to consider applying specific intelligent solution. And what's interesting, when you are starting to aggregate and make this data available for certain specific decision-making scenarios, then you're starting to see benefits even before applying intelligent solutions. And I would like to bring one of our clients, Fira, which is not only a construction company, but it's also a technological company. And when you are moving everything from being data not transparent to a data which allows to aggregate and consolidate data from the specific construction websites and to see, can we actually predict and or can we detect construction projects with potential problems before? And then once we are starting to aggregate the data and look at the so-called magical proxies, how we can predict, for example, or make a decision if the specific site is potentially encountering problems based on not direct set of data. For example, we can look at the access controls, how people are moving through the construction sites, how long they're waiting for the supplies, etc., etc., etc. And essentially, what Fira did, they started to aggregate the data into the multiple dashboards, which can oversee entire construction site or multitude of sites. And that led to dedicated centers where you can actually see what's happening with the data, and you can see and expose potential problems early on. And that's not even trying to apply some intelligent solutions, but just to organize your data, expose it to the needed decision makers, make it live and making it real time. And the FIRA today is leading actually industry also into moving certain parts from the construction site into the prefabrication, which can be done in a much more efficient way, and then move it back to the construction site. So essentially, FIRA is leading the systematic change in the construction with the potential profit improvements, which are in the industry with the pretty much zero annual growth. And looking at the taking from the cost mindset to the flow mindset, and expose the data to the needed decision makers from the opaque to the transparency. But once you actually do have data in order, then can we start applying certain intelligent algorithms? And that's what happens with our next client. Let's take a look at the weather. So we live in Finland, and we're all familiar with this type of weather patterns. And what we're observing, that the weather patterns are becoming more and more severe. And that affects a lot the business of one of our clients, because whenever there is a severe weather patterns, we have power outages, we have wiring breaks. And this client is Elenia, where it's their day-to-day business to deal with the consequences of the severe weather patterns. And the phase number one and the first approach is to understand where we have to ship the maintenance team and maintenance crews and repair teams to actually start repairing the electricity power lines breakage first, because there are very few crews always. So, and it's not continuously expanded resource. And there's like a gigantic territories where it needs emergency service. And the step number one is actually was to, again, consolidate and take all the potentially available data, which in the old times used to be in the separate Excels, accessible only to a few people, to consolidate into the very specific UI, which actually illustrates in a role-based manner. So to the teams who do have a specific need to look at the specific area and make a specific decision, how we can represent the entire area of the country and potential severity of the problems. So this is step number one. Consolidation of the data, bringing it to the control center, make it transparent for the teams that are making decision. And then once this done, the step number two, or a phase number two, because there is a huge amount of historical data with the power lines, with the outages, and with the weather patterns. Can we actually look at all of this massive amount of data that we have and start predicting what kind of a weather patterns can affect which kind of areas? So it's possible to, for example, pre-deploy teams in advance and to have a prediction, and essentially this the result of the applying this approach from the first data transparency, consolidation, and bringing it to the single place, and then to using this data in order to make a predictable predictions, and which are ranging from few hours to actually a couple of days time. And then once we have this, we can, as I mentioned, pre-dispatch the teams. We know potentially which areas will be affected first, and we can combine it in the control centers with the observation on the ground. For example, something that weather patterns are not telling you, that if, for example, the ground is frozen, the trees are less likely to fall, or the other way around, if there are still a lot of leaves on the trees, then those are most likely to fall down on the power lines, etc., etc. And what is another interesting consequence is that because all of this is being recorded, so it means that the teams can actually train and replay different scenarios that happened in reality in the past and optimize then already on the human non-algorithmic levels of what kind of a response could be driven first. So this is a picture actually from the real control center where this system is running and implementing. The Elenia published actually 2 papers based on these 2 approaches in the first efficient coordination a few years ago based on the exposing, aggregating the data, and the second part in attempts to predict the impact of the weather patterns on the outages. So as you can see, the 3 common buzzwords that we hear today, DevOps, data, and the AI or intelligent system with the prediction, and the very, very small and pragmatic steps into the approach, how we can take those forward. So concluding, I would like to emphasize that please remember, as much this is our human nature, we would like to have universal solution that is applicable everywhere, but there is really no silver bullet. We can just like learn from how we're applying something in different scenarios and make our own decisions based on that. The organizational change is one of the major impactful areas where you can make like a really significant change. So software and technology is actually rarely a problem. In many cases, that's mostly organizational change. Shifting the mindset from the observing the costs only to actually to the flow mindset, how entire operation is working, touching every part of the organizations, and the most important, touching the end clients and users of your solution or of your product, that get your data in order before trying to apply the like intelligent approaches, and first and foremost, small pragmatic practical steps and experimentation. That's how the success is moving forward. Thank you very much. If you are interested with some more technical details behind some of those solutions, there is a longer version of my talk that I did a couple of months ago at the Microsoft Tech Days here in Helsinki. And thank you very much. And let's hand it over.
Thank you, Michael. There's a couple of questions. One question is that when will AI replace software developer?
I don't think it will happen. And of course, what we are interested in, essentially the codeless solutions. So there is a very old saying in the computer science, let's program to write programs. So that's the way we would like it to be, and that's where essentially a lot of effort is going into. But to be honest, I don't see it, at least on my lifetime, where it will happen that, you know, create me this type of a product and boom, magically it appears.
So there's actually a continuing question. So if you think that software developer will be a big thing in the future as well, what would be the skills which would be taught in the universities now?
It's it's a very good question, and also spent considerable amount of time in academia before moving to the business. What I can say is that from one hand, of course, at universities and at education, we would like to teach and learn a very practical skill set, which we can almost immediately use in our professional life. At the same time, it seems like, and what we've been observing, and what, for example, Jukka was also saying, is that sometimes it means that unfortunately we are dropping off the fundamental knowledge of the systems at large. Everything depends on everything, and the communication is the key, etc., etc., etc. That it's impossible to have, like a single solution, that you have to consider multiple things, and you have to look into the fundamental areas of the science and how we approach the problems. So combining these two, the pragmatic approach and at the same time the fundamental knowledge. So this is a challenge. And that's, I believe, where we should move into.
All right. So then there's actually one more. What is the best way to sell AI for organizations?
You shouldn't sell a technical. Of course, I mean, I understand. Yes, especially if you are a company which is developing certain intelligent solution, but I don't think you should ever attempt to sell the solution. Or the specific, silver bullet, because it sounds a little bit like a silver bullet. You should first understand always what problem we are trying to solve. And then after that, be brave enough, if you see that there is absolutely no point of having intelligent solution there, to say you don't actually need this, or actually finding the opportunity and saying that in here, you can actually reduce this and that resource and make it so much more efficient if you apply here intelligent solution that can be pre-trained on your existing data, etc., etc., etc. So that's, I think, how it should be, and that's, I think, the best projects that we run in Futurice across thousands of projects and many years are actually starting from the problem. What are we trying to solve here? Instead of let's sell the solution.
All right. Thank you very much. Thank you, Michael. It was so great to have you here. It was great talk.